Mercury Part 2. So when this object hits, the size of the object, well, creates a crater about 10 times bigger than the size it hit. So if something hit and it was 100 yards across, it's going to create a crater about 1,000 yards across. So that's because it's the shock wave coming out that create this crater because of the high impact speeds and the energy that's involved with that. All right. Also notice that when you have a new crater, and you can use this to date the age of the craters. New craters have sharp edges. But over time, those edges start to settle down and it starts to get smoother. So as the crater ages, it starts to look more like this, where the ejecta is smoothed out. It still goes up a little bit, but it's nice and smooth now, where before you have a nice sharp edge. That's because over many years, Mercury doesn't have any air or water to cause erosion, but it's continuously heating up and cooling down, especially as it rotates, and especially because it rotates very slowly. Remember, it takes 58 days to rotate once. So the side facing the sun gets super, super hot, and the side facing space gets super, super cold. All that expansion and contraction of the rock is going to wear it down over time. All right, so let's look at another picture here of Mercury. Here is an older picture of Mercury. One of the interesting things is back in the 70s, they sent a spacecraft past Mercury to take pictures. And you can tell it's an old picture because back in the day, the cameras weren't very good. They only could take small square pictures. So they had to take a whole bunch of square pictures, and then they had to mosaic, essentially like a jigsaw puzzle, and put them together. And all it did was fly by Mercury. The problem is that when it flew by Mercury, only half of Mercury was lit, and it rotated so slow, it didn't stay there for 58 days to watch it. So it only saw one half of it. We just had to assume the other half was similar. Good thing about this one is you see this bright line right here going across? That is a scarp that I was talking about, one of those folds inside in the crust of the surface of Mercury. There is one more thing I didn't show you because it doesn't show up here, but if you have a new crater, you also see this lighter material that's coming out in lines. You can get rays from a crater. Rays is material that comes flying out here and makes a line on the ground. Well, the material under the surface is actually lighter color than the surface material. The surface is relatively dark gray, but the lighter material, when it hits, can get thrown out, and especially on Mercury where there's not a lot of gravity, there's no air to reduce it, it can get thrown out and make these nice lines coming out. This was a very new impact crater right there. We see those on the moon as well. Here's a better example of it right here. You see this crater up here, right on the edge? It has all these lines coming out that go most of the way around the planet. Those are rays coming from that impact, meaning it threw so much material up, that material almost went into orbit around Mercury, and then it would fall down in these long lines. You see it around these. These are all the newer craters. They have nice sharp edges, nice sharp rays on top of it. Okay? All right. This was a New Horizons. This was the latest pictures of it. Here it is from the edge. One of the other things you can do by cratering is you can look at craters, like you see this one here has a crater and there's a crater on top of a crater. Well, you can get a rough idea of dating the craters. When did the craters occur? Now, we know when the solar system formed that the rate of cratering has changed. All right, so this is 4.5 billion years ago, essentially the formation of the solar system. This is now. Well, early on, remember, it was this cloud of debris and stuff, and there were all kinds of rocks running into the planets all the time. That first few million years would have been a very chaotic time for all the planets. And the planets wouldn't have even had time to do much but solidify and then get hit again, and solidify and then get hit again. That one we had lots of cratering. But over time, this has fallen off until now. We don't see impacts happening very often, especially large impacts. They still happen, but not as often. All right, here's a closer up view of the surface. And a couple of things you can see here. You see this crater here has really nice sharp edges. That's a very new crater. This is an older crater. The edges are getting soft around the edges of it here. This, you see, it's kind of hard to see here, but you see right here, there's kind of a line that's going through there. That's a scarp. It actually cuts all the way down through here. It's a fold in the surface of Mercury. Here's another one. You can see, here's the scarp. Do you see that fold right there? That's a scarp in the surface. Here are impact craters all over. This was a very large impact crater, a large old impact crater up here. One of the things that can also happen is when you have a large impact, blows out so much stuff, some of those big chunks come out and they make these kind of craters. These are secondary craters. They didn't come from the impactor, they came from the chunks that flew out after the impactor hit. And they can cause secondary craters. Here's more close-up. You can see it. Here is a scarp too, this fold coming all the way across like this. Okay. And here's a nice crater with the central peak. Here's some with the central peak too. Typical surface of Mercury. Mercury looks like that kind of all over the whole surface. Very similar to what you would see for the moon. There is a big difference. The moon has dark seas and we don't see that on Mercury at all. Okay. Just more close-up pictures of the surface of Mercury. Mercury has no atmosphere and it has no moon. Okay. This is an old picture again, I just throw in there to show you the difference. The resolution isn't as good, but you can still see all the impact craters. This right here, you see the circle which has multiple rings. This was a really large impact a long, long time ago. It's kind of like if you take an egg and you crack it. It forms concentric circles going out. That's what happened here. The impact was here, but the impact was so large it actually cracked the surface for hundreds to even thousands of miles. All right, that's what you need to know about Mercury. So we're going to move on to Venus.